All right, example 5. It says here the straight line depreciation equation for a car is y equals negative 4,000x plus 32,000. So all of that practice we were doing in 1 through 4, it's now giving us the equation. And it's asking us, in approximately how many years will the car's value decrease by 25%? So remember, x is time in years, and y is the car's value. So it's saying at what point will it decrease by 25%? Well, if the car was 100% of its value and it's gone down now 25%, it's saying at what point will it be worth 75% of its value? I know from the y-intercept here that the new car value is 32,000. So I'm trying to find when will it be 75% of that 32,000. So when I multiply that in together, let's find our calculator. And I've got 32,000 times 0.75. And it's asking, when will the car's value be $24,000? So remembering that y is the car value, when we plug it in, that's what's going there. So 24,000 equals negative 4,000 x plus 32,000. There's our equation that we need to go ahead and solve. So remember, our goal here is to isolate x. So the first thing we're going to do, it's just a basic couple of step algebra problem. We're going to subtract 32,000 from both sides. And I end up with negative 8,000 equals negative 4,000 x. My final step to getting x by itself is going to be to divide both sides by negative 4,000. And I find that at 2 years, the car will have gone down 25% in value. All right, please press pause. Go ahead and solve this. Come back when you're ready. All right, let's take a look at it. It says, write an algebraic expression that represents the length of time it will take for the car to have a value of $d. So y is my value, remembering that I'm looking at y equals negative 4,000x plus 32,000. And it's asking, when will y be worth $d? So I've got d equals negative 4,000x plus 32,000. I'm going to go ahead and subtract my 32,000 from both sides. And I end up with d minus 32,000 equals negative 4,000x. My last step here is going to be to divide both sides by negative 4,000. So I now know that x equals d minus 32,000 all over negative 4,000. Okay, last example for this unit. Celine bought a new car for $33,600. She made a $4,000 down payment and pays $560 a month for 5 years to pay off her loan. She knows that from her research that the make and the model of this car that she purchased depreciates after 10 years. So the first thing we need to do is create 2 different equations, an expense equation and a depreciation equation. So the expense deals with the monthly payment and the down payment. So it's y equals, she pays $560 a month, x being time in months, plus $4,000 down, and that's my expense equation. Next, I need to look at the depreciation equation. And so it looks like, first off, we've got to figure out what the slope is. And it says here that the car was worth $33,600 when new. And we know that it straight depreciates at 10 years. Now we've got a little issue here before we can solve for our depreciation equation, because we can't have one equation in terms of months and the other in years. So what we need to do is to find this, but we're going to find it based on the number of months. Well, 10 years times 12 months in a year means that it's 120. So when we're solving for our slope, we're going to use that 120 instead of the 10. We've got our intercepts of 0, 33, 600, and 120 months, it'll be worth 0. Identifying my x1, y1, x2, y2, I now have 0 minus 33, 600 divided by 120 minus 0. I'm going to kind of skip a step here by rewriting it, and we're going to get negative 280 for our months. So our depreciation equation is y equals negative 280x plus 33,600. So I'm going to go ahead and identify, here is my depreciation equation, here is my expense equation. It says graph the functions on the same axes. So what I would like for you to do, can't really show it to you on here, I want you to go into your graphing calculator, and where it says y equals, you should have a place to be able to put in both equations. So you don't need to put in y equals, it's already there. You're going to put in 560x plus 400, hit enter, go down to the second one, and put negative 280x plus 33,600. And you're going to graph it. And then we're going to interpret the region. So I'm just going to kind of give you an idea. When you're looking at it here, if this is 33,600, and this is, we're going to say 120 months. I know that it straight line depreciates, and that's what the first one is going to look like. The second one is, I've got a y-intercept at 4,000 because I made that down payment, and I know that after 5 years, so we're going to say that's about 5 years, the loan is paid off. So coming across in that, my graph is going to look somewhat like that. And this intersection point is the point at which the car's value and what you owe on it is the same. So I'm going to kind of go on to the next page real quick so that we can look at this equation. To figure out how to do that, we are going to rewrite the equations and set them equal to each other. So I have 560x plus 4,000 equals negative 280x plus 33,600. Now the goal here is that when we solve for x and then we get our values, they should be the same. So I'm going to add 280x to both sides, and I'm going to subtract 4,000 from both sides. So here I get 840x equals, these values cancel out, and I get 29,600. So if we take the 29,600 and we divide it by 840, let's look at it here, try to fit it in here. So we've got the 29,600. We're going to divide that by 840, and I get X is 35.23. So what that means is at the 35th month, the car's value will equal what is owed. Before that point, somebody is what they say upside down on their car. They owe more than what it's worth. At that interception point, at that interception that we're talking about here, and let me go back to it. At this point, that is at the 35 months. And that's when their values are equal. All right, how might this expense function be altered so that we reflect a more accurate amount spent over time? And really just the answer there is we would include monthly maintenance because it goes into the value or the cost of the car. And your insurance. Now you're getting a real idea of the value of that car, and it would change the equation just a little bit. It means it's going to take a little bit longer because the cost of the car has now gone up. There's really more to it because there is monthly maintenance and there's insurance involved. And that's it for Unit 5.5. Good job, everyone.